Good morning, my dear friends. Welcome back to my YouTube channel, Coding with Vinu. Today, I am going to solve a lead code problem on March 22nd. That is, let us see the problem. They are given to count the number of complete components. We should find out the total number of complete components in the given graph. It is a concept of graph. It is one concept in graph, that is connected components. I will teach what is connected components, how to solve these components, so that you can get ready for the interview if any question with connected components is given. Let us see the problem statement. You are given an integer n. There are undirected graphs. That means it is undirected graph. No direction. That means the main difference between directed graph and indirected graph is this is one graph and this is also the same graph. But in directed graph, there will be directions. That is, this is directed graph and this is undirected graph. This is undirected graph. This is directed graph. This is undirected graph. They are given an undirected graph with n vertices, numbered from 0 to n minus 1. You are also given a 2D integer array edges. These edges are represented using an array. They are given array representation of this. For this is we should convert array into array list representation. We should convert array into array list representation of the edges. I will show how to convert this array into array list. Using array also it is easy, but I prefer using array list. For all the problems I have solved using graphs, for this I have solved using array list only. Let us see the advantage also. In this, the graph represents two, that is AI comma BA. That means AI denotes this is source. BI denotes that is destination. AI represents the source and BI represents the destination. If now we should return complete connected components. This is the main, the whole answer depends on this keyword. What is connected components? Connected components, here they also given the definitions, but I will make you understand what the connected component easier way. Here they have said that it is a subgraph of graph in which there exists a path between any two vertices, and no vertex of the subgraph shares an edge with a vertex outside of the subgraph. That means it is a graph. It is a subgraph. Subgraph means it is one of the component of the graph in which there exists a path between any two vertices. That means connected components is, let's suppose we have a graph. In this way, we have a graph. For a connected component, it is a connected component, if we take this as subgraph, this is the subgraph. This is the subgraph. This is the graph. This is the subgraph. For the subgraph, it should be path between two vertices. Here it consists of path. Here it consists of path. And no vertex of the graph shares an edge. If suppose this is the external edge, external node, it should not contain an edge to it. It is called as connected component. A graph is also a connected component. Graph is also a subgraph of itself. I hope this point is known to everybody. That is, a subgraph is a subset of the subgraph. Now, another main word, that is complete connected component. What is this complete? Here they also given what the definition. Here they given the definition. A connected component is said to be complete if there exists an edge between every pair of its vertex. Let us take an example. What is complete? What is complete? Complete means there should come all the nodes, note down this point in your notebook. Please maintain a notebook because at the time of revision, we can easier. I too will maintain a notebook. At the time of revision, I would be forgotten the graph concepts. Whenever the question is given on graph, I once go through the revision, revise the notebook, and try to solve the problem. All the nodes to be connected, all the nodes to be connected, all the nodes to be connected to each other. All the nodes should be connected to each other. That means if they have given, if they have given in the before graph, it is a subgraph. It is a complete graph. It is a it is a connected component. Let's see whether it is a complete or not. Complete or not. Complete or not. A graph is said to be connected complete when every node will be connected to each other. That means for this it should be connected to these two other each other. Yes, it is connected component. For this it is a connected complete. For this node it is connected to only this node. It doesn't have the component to edge to this node. So it is not a complete, not a complete. I think all have understood what is the complete connected component. Let us see an example. Here n is equal to 6. Example, I will discuss about this example only. They have given an edges is equal to 0, 1, 0, 2, 1, 2. It is timeless. Here also the same example is given. They have said that we should connect an edge. Let's suppose I am telling you from basics, my dear friends. Please understand the problem. I have already discussed what is complete connected components. Now they have given 6 vertices. That is n is equal to 6. They have given from 0 to, we should take 0 to n minus 1. It is 0 vertex, it is 1 vertex, it is 2 vertex, it is third vertex, it is fourth vertex, and fifth vertex. They have given an edge between 0 to 1 edge, 0 to 2 edge, 1 to 2 edge. Next, 3 to 4 edge. 5 is single element. The edges will be looked like this. The edges will be looked like if we properly draw these components. These are connected components. This is connected component, this is connected component, and this is connected component. Let us see, let us draw clearly the connected components. The connected components, this is 5, this is 0, this is 1, this is 2. These are all connected components. But we should find out whether these are all are complete or not. For to be complete, it should connect the all the nodes on the given components should be, it is first, it is second, it is third. For all the nodes, it should be connected to each other. Here we keep track of answer variable. Answer variable. It is a connected component where let's check for a completeness. For completeness, it is connected to each other. That means it consists only one and it is connected to each other. So this is initially 0. It is a completely connected. Let us go to the next point. Whether it is connected it is connected component. Here this node is connected to this both. This node is connected to this nodes. This node is connected to these two nodes. So this is also a complete node. So we increment the answer as 2. Now this node is connected to this. This node is connected to this. That means every node is connected to each other element. So this is third element. I hope what answer as 3. Let's see, yes, the output is, answer is 3. Now, let us see how to solve this problem. Let's take one example. How can we check whether a given component is connected component or not? How can we check? Let's take an example that is 0, it is 1, it is 2. Now, to be connected components, let's check how many number of nodes are there. Nodes are nodes are 3. Let us check how many number of edges edges are there. Edges are also 3. That is, it is coming as nodes into nodes minus 1 by 2. Which if you want to check for every node, it will satisfy this statement. Nodes is equal to nodes. That is 3 into 2 divided by 2. That is equal to 3. See, my dear friends, here nodes and edges are depending like nodes into nodes minus 1 by 2. That is satisfying. It is true. It is true. Let us see for another example. That is, if we take for above one, that is 3, 4. Here, nodes are 2. Edges are edges are 1. Let us check for nodes into nodes minus 1 by 2. 2 into 2 minus 1, 1 by 2. That is 1. I think everybody have understood what is the relationship between nodes and edges. This is the relationship, my dear friends. We have to find the relationship between, anyhow we should solve the problem using some relationships. For this, to iterate through all the components, to iterate through the connected components, we can use BFS and DFS. We iterate through the graph. For iterating of the graph, yesterday I have discussed about the topos sort. Today I am going to discuss another interesting traversal called as depth first search. That is depth first search. For the next problem, I will sure solve the problem using BFS. This is now today I am going to discuss about DFS concept. DFS. DFS is a depth first search. Depth first search. Depth first search. We iterate through the depth first. That means we go on iterate through the adjacent elements. We go on iterate through the adjacent elements. Initially, we suppose the graph as 0, 1, 2, 3. Let's suppose this is the graph. Let's suppose this is the graph. Initially, we keep an initially we keep a visited array of type boolean. Initially, all are initially kept as false, 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 because all are false. We iterate through the all the elements. That is, for iteration, we use for loop. That is, we iterate through the I is equal to 0 to n elements. We call them if it is not visited. If it is not visited, if it is not visited, current element, that is current element is I. If it is not visited, we call a function DFS function. We call the DFS function. Let me, we call the visited of I. We call the DFS function. DFS function consists of current node element and Boolean visited array to make them as visited. In DFS function, it is the current source and visited array. When we call this initially, the element is not visited. We first initialize visited source is equal to true. That means I have came to you. It tells that I have came to you. Make it this element as true. Understand, my dear friends? I am making similarities and comparing with how to easily understand the graph concepts. That means DFS first does that, make this current source as true, and we iterate through the adjacent elements. That means if suppose we call this function 0, initially we call for the zeroth element. If we call for zeroth element, make this as, initially it will be false, make this as true, and iterate through the adjacent elements. What are the adjacent elements? Depth first search. We keep an answer array. If you want to find out the answer as 0, and we iterate through the adjacent elements. How can we get adjacent elements? Let adjacent elements is equal to int adjacent in, it consists in the edges dot get of source. If we, I will explain this, how this, what is this adjacent dot get of source in the next concept videos. I am planning for the concept videos. I will surely will make every concept clear and crystal clear. We iterate through the all the adjacent elements. We iterate through the adjacent elements and make that if it is not visited, if it is not visited, if it is not visited of adjacent elements, we call the DFS function for those adjacent elements. We call the adjacent elements and we keep visited array. I hope this is the simple code, my dear friends. DFS function. I make I have made this using the not an example, how to build. I have discussed how to build this DFS function. Here, I will make the DFS separate video and will explain you clearly. This is the DFS function. For every DFS function, we should calculate nodes, that is, number of nodes that should be iterated, should be incremented. And we calculate the degree sum. We should calculate the degree sum. That is, this degree sum denotes that how many adjacent elements, how many adjacent array elements, adjacent elements are there, or adjacent elements or adjacent edges are present. This degree function denotes this, degree sum denotes this, my dear friends. If after iterating through all the elements of DFS function, we calculate whether the calculated degree sum is equal to nodes into nodes minus 1 by 2. Another, my dear friends, we can check, all of you know that number of edges into 2 is equal to degree. Here we calculated edges as n into n minus 1 by 2 into 2 is equal to degree. If the degree is same as calculated, so we can minus this. If we calculate the degree as nodes into nodes minus 1, then we increment the answer. Or else, after iteration, we return the answer array. Here we can see the code. This is the initialization code in which we are given an array of edges, We are given array of edges. We should convert them into array list. For conversion of them into array list, we use this code. That is, we create an edge It is since it is undirected graph, we make the edges from source to destination and destination to source. This is to create an edge. We initialize array list and we keep an iterating through the all the elements in the edges and we create an edge. Now we make visited array. We make an visited array. This is the DFS function, my dear friends. DFS function. DFS function. I have explained clearly what here DFS function explains. DFS function. After iterating through all the DFS function, we calculate the nodes into nodes minus 1 by 2. Here, nodes into nodes minus 1 is enough. If it is equal, then answer will be incremented. I hope this is clear to all of them. So please, my dear friends, please subscribe to my YouTube channel and share with your friends. Please subscribe to my YouTube channel, Coding with Vinod, in which you can get. Now I am planning to discuss about concepts also later. Later I will how easy the concepts are, data structure concepts are easily can be understood. If you subscribe to my YouTube channel and press bell icon, press bell icon to get immediate notifications to your phone. Whenever I upload my video, you will get an immediate notification on your mobile. Thank you, my dear friends. Share with your friends also. Let's meet on tomorrow with another interesting question. Thank you, my dear friends.